When it comes to mapping the galaxy, astronomy has a very strict traditional rule. To find something out there, you have to catch its light. You either look for the light a planet reflects, or you look for the sliver of light it blocks. But that method hits a hard limit very quickly. To catch a planet's shadow, telescopes need the host star to be relatively close to our solar system, or we need the planet to pass perfectly in front of it from our perspective. That creates a major blind spot when we look toward the center of the Milky Way, into the constellation Sagittarius. Out here, 7,000 light-years away, the space is choked with incredibly dense gas and chaotic clouds of glowing red dust. Standard optical telescopes are effectively useless in this environment. If there is a tiny, freezing ice planet orbiting a dimly lit star out there, humanity has zero chance of actually seeing it. Relying on light alone leaves most of the deep galaxy unmapped. To find the hidden worlds buried in that darkness, astronomers had to stop looking for light and start feeling for gravity. That is the exact strategy of the MOA-2 survey, an operation running out of the Mount John University Observatory in New Zealand. The astronomers here don't point their equipment hoping to spot a distant planet directly. Instead, they stare at massive fields of distant background stars night after night, waiting for a very specific statistical anomaly. Gravitational microlensing requires 3 points: Earth, a distant background star, and a roaming foreground star. When the foreground star perfectly crosses the background star's path, its massive gravity warps spacetime, bending the faint distant light and focusing it toward Earth in a sudden flare. For a few brief days, this creates a cosmic magnifying glass. It opens a fleeting window into the dark, allowing us to detect objects that are entirely invisible on their own. On May 24, 2007, the MOA-2 team topped one of these alignments. Starlight from a distant system rapidly intensified, signaling that an invisible foreground star was passing through our line of sight. This chart maps the brightness of that event. The massive primary peak is expected from a star crossing the lens, but as brightness faded, it spiked a second time. That secondary blip proved the star had a planetary companion tugging on the lens. Initially, researchers miscalculated the scale of what they had found. Because of a parallax error, a mistake in measuring the exact angle and distance of the passing star, they estimated the host was a substellar brown dwarf, possessing just 6% the mass of our Sun. But further analysis resolved the math. The host, officially cataloged as MOA 2007 BLG 192L, is actually a true red dwarf star, containing nearly 30% the mass of our Sun. With the star's actual mass corrected, the dimensions of its companion came into focus. The planet is a frozen world orbiting roughly 2 astronomical units away from its star, classifying it somewhere between a heavy super-Earth and a sub-Saturn. Correcting that single assumption about distance changed the classification of this system, shifting the host from a mere substellar object to a true burning star with a newly confirmed icy planetary companion. But microlensing events are strictly temporary. As the foreground system continued its orbit, the alignment broke, the warped spacetime shifted, and the magnification vanished. Today, MOA 192b has plunged back into total invisibility. It is too small, too dim, and too incredibly distant to observe directly with any technology currently on Earth. Yet, despite disappearing entirely, it is permanently etched into our star maps. We know exactly where it is, entirely because of the invisible gravitational shadow it cast as it crossed our path. This detection suggests that many of the red dwarf stars that make up the majority of our galaxy likely host their own hidden planets. We may never see them shine, but their gravity ensures they cannot hide from us.